Hello friends, in the third lecture of Basic Organic Chemistry, I heartily welcome all of you. Friends, in the previous two lectures, we have seen classification of organic compounds. We have seen organic compounds are classified into four main types: organic acids, phenols, organic bases, and neutrals. In the previous two lectures, we have seen organic acids, phenols, and organic bases. Friends, in this lecture, we are going to focus on neutral compounds. Organic neutral compounds consist of different functional groups such as hydrocarbons, aldehydes, ketones, ethers, alcohols, esters, anhydrides, amides, and urea. This lecture is devoted to the neutral compounds. So friends, in this compound, initially we will discuss hydrocarbons and then aldehydes and lastly ketones. So what is meant by hydrocarbons? Hydrocarbons means the compounds which are made up of carbon and hydrogen atom only. It may contain single bond, double bond, or triple bond. Those hydrocarbons which are acyclic in nature are known as acyclic hydrocarbons. Acyclic hydrocarbons are divided into three types, that is alkanes, alkenes, and alkynes. And the compounds, those are cyclic, are known as alicyclic hydrocarbons. So friends, you might have studied the alkanes. Alkanes means it is a saturated acyclic hydrocarbon and it is represented by general formula CnH twice N plus 2. This family consists of different compounds. Its premier compound is methane, then ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Second acyclic compound or hydrocarbon is alkenes. Alkenes having a general formula CnH twice N plus CnH twice N. So this family consists of starting compound, that is ethylene, then propylene, then butylene, then pentylene, then hexylene. In this way, we can derive several types of compound. So in this compound, there are isomers also, butylene, isobutylene, pentylene or isopentylene. Then third type of acyclic hydrocarbon is alkynes. Alkynes are also unsaturated compound, but it contains triple bond. While alkenes CnH twice N, it contains carbon-carbon double bond. In alkyne, there may be triple bond at the terminal position or in between two different carbon. So the first member of this family is ethyne. Then you can write propyne. So ethyne is also known as acetylene, propyne, butane, pentyne, hexyne. In this way, we can derive several compounds in this family. So all these three compounds, alkanes, alkenes, and alkynes, belongs to acyclic hydrocarbon. So friends, hydrocarbon may be of cyclic type also, and this cyclic hydrocarbons are also referred as a alicyclic hydrocarbons. Alicyclic hydrocarbon which are saturated are represented by general formula CnH twice N. So we will get cyclopropane, cyclobutane, cyclopentane, cyclohexane. These are the alicyclic saturated hydrocarbons. Similarly, one can put double bond in alicyclic compound such as a cyclopropene, cyclobutene, cyclohexene, etc. And these alicyclic compounds can be derived another way, uh, like in alkynes. So one can put the triple bond in alicyclic compound also, and we can derive such compounds. So friends, these are the hydrocarbons, um, saturated or acyclic hydrocarbon. But along with this, there are aromatic hydrocarbons also. These aromatic hydrocarbons are made up of carbon and hydrogen bonds, but its pattern is quite different. It contains alternate double bond. It is a though it is involved or it is included in hydrocarbon, but it has certain different properties with respect to alkane, alkenes, alkynes, alicyclic hydrocarbons. Aromatic hydrocarbons are highly stable. It is cyclic one, planar one, and contains alternate double bond. The first important aromatic hydrocarbon is a benzene. It is discovered by August Kekulé. So this is a benzene, and this benzene having a alternate double bond, and it is purely made up of carbon and hydrogen atom. Second one is naphthalene. So this naphthalene is also aromatic hydrocarbon having a two rings fused to each other. Therefore, uh, this is the bicyclic aromatic hydrocarbon. So this is a tricyclic aromatic hydrocarbon having a three rings are get fused to each other, and this compound is known as an anthracene. So next compound is made up of three rings, but the fusion of this ring is quite different. In anthracene, three rings are fused to each other in a series, but in phenanthracene, two rings are fused in series, but uh, third ring get fused randomly. Therefore, this structure is known as a phenanthracene. Our next neutral compound is aldehydes. So friends, aldehydes are nothing but carbonyl compounds. These are carbonyl compounds having a functional group RCHO or ARCHO. So friends, these are very important compound in organic chemistry. So these aldehydes plays important role in nature as well as in human being. So the first compound in this functional group or neutral family is a HCHO. This is known as a formaldehyde or methanol. So second compound is CH3CHO acetaldehyde or ethanol. Next compound is CH3 CH2 CHO. This is a propanol. Then one more compound, that is a CH3 CH double bond CH CHO. This is a unsaturated alpha beta unsaturated aldehyde, and name of this compound is crotonaldehyde. This crotonaldehyde is very important in pharmaceutical industries. Next compound is, this is a pH CH double bond CH and CHO. Again, this compound is alpha beta unsaturated aldehyde. So this is the aldehydic functional group, and this is alpha carbon, this is a beta carbon, gamma, then delta. Likewise, as alpha and beta carbon consist of unsaturation double bond, this is known as a alpha beta unsaturated aldehyde. Name of this compound is cinnamaldehyde. So friends, this cinnamaldehyde is used for the diagnosis of allergic contact dermatitis, ACD. Fluconazole is used in studying the treatment of HIV. So this is the fluconazole. Uh, this is the structure of fluconazole. It is very important drug in studying the treatment of HIV. So this is the uh, benzene ring having a acidic functional group, carboxylic group, and again this is one ring having a aldehydic functional group. So this functional group we are discussing on neutral compound aldehydic functional group. So this is the aldehydic functional group present in fluconazole, and this is one OH group, and two rings are uh, joined to each other by oxygen function, and whole this structure is known as a fluconazole. Friends, the compounds which we discussed in aldehyde functional group were open chain aldehydes, but there are some aromatic aldehydes also. This aromatic aldehyde consists of different compounds. So this is a aromatic ring, and ring having a one functional group CHO. This is a benzoaldehyde. So this is a naphthalene ring, and this naphthalene having a CHO group attached to the second position. This is a 2-naphthyl aldehyde. Then third compound is again benzene ring having a CHO group. This is a benzaldehyde, and to the para position of benzaldehyde functional group there is one chlorine. Therefore, this is a para chlorobenzaldehyde. So friends, one more compound is there. Same structure is there, just change in substituent group. In previous compound there was a chlorine, but in this compound there is a nitro group. Therefore, name of this compound is para-nitro-benzaldehyde. So friends, this is more one more compound having more substituent. So this is a basic compound benzaldehyde, and uh, this second carbon and fourth carbon having a 2 chlorine atom. Therefore, name of this compound is 2,4-dichlorobenzaldehyde. So, after aldehydes, we have to discuss ketones. Ketones are also carbonyl compound. These are organic compounds which contains carbonyl group. But there is a vast difference in aldehydes and ketones. Aldehydes also contain carbonyl group, but in aldehyde there is a one R group, and in another side there is a hydrogen, and carbonyl group is flanked by one R and hydrogen. R may be aliphatic, R may be aromatic. But in ketones, carbonyl group is flanked by uh, R group or AR group, or one R and another AR group. So this is the basic difference between aldehydes and ketones. These aldehydes and ketones are a very important compound in organic chemistry. So this belongs to neutral family. So friends, these are some compounds, ketone compounds. This is open chain ketones. The first member of ketone is acetone. Common name is acetone, but according to IUPAC nomenclature system, it is a propianone. Then second one, this is a CS3, CO, CH2, CS3. On second carbon, there is a carbonyl group. Therefore, this is a 2-butanone. Just I have shown butanone, but the correct IUPAC name of this compound is 2-butanone. Then next compound is CS3CO CH double bond CH2 butane 1 in 3 on. So this is the compound. Then next one PHCOCS3. So this is a common name of this compound is acetophenone, but IUPAC name is 1-phenyl ethanone. So 1-phenyl ethanone, sorry. Next compound is benzophenone. So this is a ketone having a 2 pH group attached to the carbonyl group. So friends, these aldehydes and ketones are very important pharmaceutical reagents, or it may act as a precursor to produce different types of drugs in pharmaceutical industries. Apart from pharmaceutical use, ketones may be used in another sector, another fields. Acetone, commonly this ketone is used as a solvent for resins, lacquers, and cellulose. Ketones, this acetone is very important solvent in paint industries, dyes industries, lacquers in different mm, work. So camphor is a ketone. This camphor, another ketone, is used in liniments and insecticides and in the manufacture of celluloid and lacquers. Ketones such as a sevitone are used in making perfumes. Then ketones also are used in making flavoring dyes, chloroform, and plastics. Friends, uh, there are more neutral compounds. We'll discuss it later on. Thank you very much. Thank you.